So, hello everybody. Thank you, Tal, for introducing me. Yes, I'm a product and development engineer from August Storm, and today I will present about how we introduce for the Storm Group a new Sub-Tenant for our daughter company Koedood, and we name the product there Koedood Engine inside. So, we have here already, you see that in the picture maybe, big combustion engines. That's actually our use case. For Koedood, it's mainly Mitsubishi engines. So, who we are? The Storm Group, we have several companies owned by family Storm. The August Storm GmbH is now 87 years old. We were founded in 1937. And then we have Wolf Johansen, for example. They do pretty much the same like we do. We are both manufacturer-independent service company for combustion engines up to 7 megawatt power output. And Wolf Johansen is even older than us. They were founded 5 years older than us. They are already 92 years old now. And then we have several different newer companies, also data companies from Wolf Johansen, for example, or Scandiesel. They do mainly Scania engines. And the newest part of the Storm Group is Koedood. And yes, I will tell you more about them in a few slides. What? Oh. So, some news from our Storm Group. What we have just founded is a Storm Innovation Group beginning this year. So we want to have more collab in between our developers and engineers over the whole company group to improve our development speeds and stuff like that, to be more efficient. We had already like a nice kickoff in January at the Fraunhofer in Berlin, and we had there also some nice inputs of them, saw there's some technology by them, also got a nice presentation about digital twins, especially useful for Cumulocity. Then from the Koedood side in January, we had also a visit by the Dutch King, so a really important visit. He was there for like the maritime manufacturing industry. They visited like the smart Delta grid in that region they have there in the maritime industry, and one of the companies he visited was Koedood. And the good news for me, many of you maybe saw me already last year presenting on StormEye, our product from August Storm. Back then I was more or less alone developing everything around Cumulocity without any programming background. I'm just an engineer. And just like 2-3 weeks after the last IOG, I had the good news, the software developer is coming. He's probably now on the technical track, listening there, Lucas, and he did already give me great support and is programming nice stuff for us. Also developed the data gateway based on FinEdge, but I will tell about that more later. Some nice news about our oil condition pilot. We have an oil condition pilot running with a big oil company. I'm not allowed to name them until now, but probably everybody in the room knows them. Yeah? And what we do there, we install this extra sensor. It's based on conductance and capacity, and it can detect pollutions in oil up to 100 ppm. And then we go one step further. We have a data package with average values over 1 minute of the engines together with the oil sensor data. We give the data via API to the oil company. They have an ML model behind that, and yeah, they pretty link it to real oil sample oil analysis, and then they can predict permanent the most important oil quality values like 10, that's the acid number, or the TBN base number, or also oxidation or nitration. So, Koedood Marine Group, you can here see like an air view of the company. It's directly located at the Water Street close to Rotterdam, Hendrik Ido Ambacht. This here in the front is the new company building. It's around 7-8 years old. Pretty nice facility. And we have also like the backyard area here, overall there, directly at the water. And we have there a dock where we can have 3 ships, inland ships, for exchanging engines, doing service and stuff like that directly there at the location. So Koedood was also founded pretty early already, old family business, family Koedood. They founded them already over 60 years ago. And what's their business? How I mentioned before, mainly Mitsubishi engines. They are the biggest dealer for these types of engines in Europe. And they also develop based on the existing Mitsubishi engine, the Koedood Stage 5 engine, because for Mitsubishi was the European market too small to be compliant with the newest emission regulations, Stage 5. So what did Koedood? They packaged the engine new with a new control system and exhaust after treatment system to be compliant, certified the whole stuff, and now they even on paper official engine manufacturer just by packaging the Mitsubishi new. Then we have also other products by Koedood Marine Group. We have another company there, it's called Green. You can see the little logo here at the entrance. Green, it's all about emission. They develop exhaust after treatment systems, mainly for seagoing vessels, but also inland shipping. And then we have fuel cell systems developed by Koedood themselves in different sizes as genset applications. There are sizes available like smaller ones, 50 kW or 80 kW. The big ones are really big. They have like the size of a 20-feet container and have a power output between 300 and 500 kW. So, what's our business case with Koedood Engine Insight? I have here a little comparison between our mother company, Storm, and Koedood. So Storm is focused all on manufacturer-independent service. We do diesel, gas engines, everything, and we think there is like the most benefit for us. It's a build service and a customer binding tool so that they order in future more service by us, and we can automate that also by linking it with smart rules to automatic emails by maintenance alarms so that they can plan with their B2B managers directly in CC by an email like the next maintenance steps. And on the Koedood side, we have mainly the focus now on the diesel engines, the Mitsubishi engines. Probably we see also fuel systems in the future, and we see the benefits there that we want to have better insight about our own products, and we also see the option to use this as a development tool. Little fun fact, my first work with Cumulocity was developing an SCR control system for gas engine, and I validated that with streaming analytics. Then the long-term goal for both companies, we want to build a maintenance support system and fleet management system with performance data, but especially on the Koedood side, over long term, we want to lower the maintenance cost of their own products so that they are more attractive in the market. So the market potential, we have the current market focus. It's first the Stage 5 fleet, because we have to develop the engine control system. It's pretty easy for us to get all the data out of that, and we want to implement it there as a standard. The first 12 months we will give it for the customers for free. And in the market we sold around 120 engines in total. These engines are slightly different from engine to engine. They're different sizes. The combustion chamber is every time the same, but they exist as 6-cylinder engines, 12-cylinder engines, and 16-cylinder engines. The smallest one, the 6-cylinder, has 660 kW power output. Next step is that we go to the seagoing newest exhaust emission regulation, the IMO Tier 3 engines of Mitsubishi. We have there already a really good request because there's a new fleet in the build with 30 ships, and each ship has 3 engines on board, so we have there possible 90 extra engines we can implement with the build of this fleet. And we see also, like in the future, the possibility to go for older engines from Mitsubishi, but that's really difficult because they are really mechanical based and you don't have that many measurements on them. So we probably have to build there also retrofit solutions with special sensors and stuff like that to get really useful data for the customer out of them. Or also the other products like the exhaust after treatment systems from Green, or of course also like the fuel cell systems, but we also offer electrical propulsion engines, because depending on the packaging of the engine, we have also direct propulsion engines. We have, but also like diesel electrical, so that they go for fixed speed, as a gen said, produce the energy, have a battery pack sometimes in between, sometimes direct, and then electrical propulsion engine at the end. Yeah, some little fun about our brand, or the way to the brand. On the left side, you see the mother product, Storm-Eye, and based on that, we were like, oh, how can we name the Koedood? Well, let's make it easy, let it call Koedood-Eye. But then came my boss, Bernhard Storm, and was like, let's make I, in Japanese, make it to Koedood-me. Me is the Japanese term for I. But then came the Dutch marketing, was like, we can't do that, because the family name Koedood, in combination with the word me, means in Dutch, the cow kills me. So what came the Dutch marketing up with was then Koedood Engine Insight, our digital performance and service dashboard. Yeah. So let's go to the Sub-Tenant. That's a structure probably many of you know. Like you have your management tenant on top. That's where we have our experimental machines mainly from the first state from working with Cumulocity. And now, step by step, we introduce further subtenants, like we already introduced for our paying customers for the ECOS business from Storm. That's our stationary engine business unit, a subtenant where we have the paying customers in. We also will do that for Mobis pretty soon. Mobis is our mobile application unit from Storm. Yeah, then now Koedood engine side, and we plan to go for big fleet customers with separate subtenants to have better management. Smaller ones we just will manage by inventory rules. A little about the branding. Yeah, we just use the inbuilt function of the enterprise product from Cumulocity. Here you can see like the preview of our home start page. We work a lot with HTML code to give some further information. Like here we have on the top like a welcome with HTML with our support email address. On the right upper side, we also give some HTML for giving news about our own developments in case of microservices and stuff like that. And we also have like general information. We have also on our homepage from Koedood about Koedood service and Koedood parts. It's more down here, but you can't see it from the screenshot. Yeah? And we have there like a 24/7 emergency hotline so that they can get every time parts, spare parts, and service from our side. So if they have now a problem and they see it in Cumulocity, they directly can go to the start page and check the contact information. Yeah. Let's come to the gateway. In the first step, that was a pretty difficult journey. From my side, I wanted to go in the first step directly to Kunbus or another PC for introducing separate hardware from the engine control unit. But yeah, how it sometimes is, the management wanted to save hardware costs and were like, program that on the existing engine control unit. And that's like a Bachmann PLC we use there. And the issue was the CPU load was already pretty high. And with all the connection to Cumulocity and certain points, we did it on a first ship with testing and everything. I had a nice day there, debugging it on board. And we saw over time, the first days was really good, but then there was some issue on the engine control unit and the MQTT broker stopped. And it's not really easy to restart the engine control unit remotely to have a connection again. So we went then the Kunbus approach. Yeah, Lucas, a software developer, he built the software with FinEdge, also with Node-RED. And we have a real cool, adaptable user interface with Node-RED, where we can now configure FinEdge. We can here do the FinEdge registration via directly via the Node-RED UI, for example. And we have here other tabs we can open. Yeah? For example, the Modbus master, where we can just exchange the Modbus JSONs to connect other engines. Yeah. So the communication structure, we have on-site currently, what I mentioned already, the ECU, then the connection to the data gateway, depending on our business. We do that with CAN bus or Modbus, sometimes even some other communication protocols. Then we also think it's the option to integrate in future also optional other PLC systems to monitor like tank volume and stuff like that, or even like extra sensors like the oil sensor I mentioned before, but we also are already thinking about developing other sensor systems in future to get more out of like the engine condition. Yeah? Then that goes all to Cumulocity IoT. And on the other side, we have some API services. Yeah? So, for example, the first one here is the exchange with the big oil company for giving them the data we prepared for them for their data analysis. And when we finish a pilot, we also want to get the results back to Cumulocity. We didn't do that yet. We also see it as an option as an output, or also probably an input from our own system or customer systems. Like we have a service technician portal. It's called Engine 4 in-house, and we have there like all the maintenance information from our company. When is the next maintenance and stuff like that. That would be really nice information to have also in Cumulocity from that side. But on the other side, they could also need like automatic generated like requests, for example, in case of maintenance from our side. And then we also use like some external API data already. Especially here, we integrated an AIS microservice. I don't know, do you know what AIS is? It's like the International Positioning Service for the vessels and ships worldwide. So if you want to check that, you can go, for example, to Marine Traffic on their homepage, and you get a world map with many, many arrows where the ships are all going. And we introduced a microservice where we just have to configure as a property to the device the MMSI, that's the registration number. The microservice registers that MSI is configured, and then it directly fetches from the AIS stream the positioning. So we also, with Koedood, introduced the first time multi-language, because our Storm customer base until now is German, yeah. So we use their only German language until now. But on the Koedood side, we have the Dutch colleagues, we have their international fleet customers, so we introduced their, at the current state, 3 languages for all the stuff like Dutch, German, English. Yeah. And now let's come to the really cool example. So my example are the river drones today. That's the first fleet customer we are currently integrating. Here you see at the right side the River Drone 1. The river drones are a small fleet. They finished the build now in April or March of the total fleet of the whole 10 ships. And they are owned by Naval Barging. And Naval Barging has a total fleet of 65 vessels for inland. And yes, these ships are have all the same engine type, so it's pretty nice. We have there already like an engine base. Then if we have them fully integrated, currently have like the half fleet of 20 engines with the same packaging. So pretty nice also for data collection, for machine learning, stuff like that in future. So what these, especially on the river drones, they are semi-autonomous, and they only need a really small crew, about 3 to 5 people only on board to control all the technical stuff and do the landing maneuver. And they can be controlled by the captain remotely. And that's the cool thing, I think, about that. Also, maybe a nice marketing case in future. So we also implemented there some standard functions like the live data dashboard, the maintenance dashboard. Also, we already calculating in the background with analytics some smaller performance data already. And I got from their technical supervisor just 2-3 weeks ago a request to configure him smart rules to give the upper limit for the fuel consumption for the engines because they want to save diesel oil. The price is pretty expensive. But I probably will make another approach soon because the threshold smart rule triggers too often. So it's better to have like a certain time period over time, but I can quickly do that with Analytics Builder. Here you see the live data dashboard. That's like when the engine is starting. See, we have different widgets that we use there, like the info gauge, where we have like data about the operating hours, the NOx emissions, but also the engine load and the fuel consumption. We see here we had a pretty low engine load. It's only 6% of the 100, and the engine is already consuming 60 liters per hour, so you can imagine the size. Yeah, we also get the alarms from the engine control unit. We implemented them too. We have, for example, the first alarm is a sensor defect. Yeah, then we get the RPM speed. It's not really that interesting on that engine because it's fixed speed. You only see it when it starts up that it's moving. After that, it's only like going around 1800 RPM. And then we have the different curves of different temperature values, pressure values. In total, we integrated for these engines around 30 to 40 data points, depending on the packaging. Then we have here the maintenance dashboard. I implement the maintenance schedules with streaming analytics also, and just pick up the operating hours value, and based on the operating value, I publish notifications in a certain amount depending on the maintenance work so that we have enough time to plan the maintenance. For smaller stuff that the crew can do themselves, we use like 50 hours only, but for bigger maintenance, we do several 100 hours. For engine revision, even in the gas engine market at Storm, about 2,000 operating hours before that we have enough time to plan the exchange engine or to get all the parts together and have the smallest downtime possible. Because downtime there especially is money. The engines have to run to produce energy. So, and the stationary energy, yeah. What we also introduced there is a custom widget. It's the data capture widget. It's a community plugin. I think Christoph Strack developed it. And when we tested it, it was only in English. And so I said to Lucas, can you make that multi-language? And he did. And we also created a pull request on GitHub. We talked to Christoph 2 weeks ago. He accepted it, so it's now also available in free language from our side. And what we use the data capture widget for is that we fetch with that the maintenance work that is done by the crew, for example. Like we have here, like the possibility, we have here like a couple of data points, like last oil sample. When you took the last oil sample, you put in the operating hours value with the date, and we have like a comparison, and we also use here like properties. I think I also have a laser. Huh? Oh, doesn't work. We have also here like properties where we use them so that the customer can configure his own sample interval or oil drain interval manually, and in the back end we link that in the analytics builder, and then we publish by that the notifications. We have in the alarm widget there the next oil sample notification. So here's just a small vessel overview. There you see on the top the positioning, the map. That's just AIS data. So AIS, it doesn't come in the frequency like our data. We publish the data in every 2 seconds to the cloud in one message. So that's also pretty unique, I think. Not many people do that. Yeah, and we have here also overview, and in the tables on the button, we have for the starboard and the port side engine the performance data I mentioned earlier. So we calculate their the average engine load over the day, fuel consumption, urea consumption, stuff like that, so that they have that for their fleet management already available to make some statistics about the total consumptions of the ship. So, like I mentioned before, we do multi-type measurement, and that's sometimes an issue. And we had some, and let's go first. We have currently still data export issues. I had a big feedback call with Cumulocity, and I really think I don't want to complain here. What I want to say to the community, use the feedback tools. Use AHA, use the support incident portal or the tech forum, and let the people know what your problems are so that they can work on it and help you. And we have, for example, the problem with the Data Explorer, that if we go to the portal, we see the filtered measurement correctly. But when we export it, because it's all in one message, we get all measurements over the time series, and no filters are applied to the Excel or CSV file. But we got already the feedback from R&D that they want to work on that with the migration of the Data Explorer to Angular. So we have already their feedback that they are working on it, and I really appreciate that. With the scheduled export, we tested that also. I see there are also some minor issues. There's almost the other way around. If I use the analytics builder, I create single measurements, but I use with a cron timer the exactly right timestamp, and then I get a table with like performance data, like the 4 or 5 data points of performance data every day, and I want to give a nice Excel sheet as an export. And what does a scheduled export? It produces for every data point a single column, but also a single row, but all have the same timestamp. And then you have like 5 rows with the same timestamp and only one value per row, and all the other values is written NA for not available. And that's not that beautiful, I think. But they are checking it already. Yeah. Then we have also visualization issues. We had one with a data point graph widget that we were sending without units, the measurements, and we applied units by the data point library, and the data point widget wasn't capable of displaying the unit then on the data point graph. But R&D did their really fast fix within 1 week, I think, and then they just gave us the new version, and now it's working for us. And then we have some minor bugs still in the visualization, but we reported that. They found the issue, it's on our side. We have some mistakes in our bending files, so we have to rework on that. Yeah? But we will probably fix that within the next weeks. Shouldn't be that difficult. So, what are for us the next steps? That's pretty easy. The first step is we need to scale up, we need more engines. So, first step will that we integrate the whole stage 5 fleet, the whole 100, 110 engines we have already in the field. And with the first fleet, it's currently the state, or was the state 2 weeks ago, we integrated 4 ships already. I don't know what my Dutch colleagues are doing this week, but I know that River Drone 3 is in the shipyard. I hope that it's live next week. Next step then is to the adaptation of the gateway to MOT3, so that we can enter that market too. We have already prepared the address list for the overall exhaust gas system, but because the engine control is different, we still have to check how we get like important values out of the engines, oil temperature, stuff like that. Yeah. On the right side, you can see the classical 6-cylinder engine we monitor. You can also see like the exhaust after treatment system on top. It's really big. Like it's in total, I would say the SCR box is more or less the size of half of the stage. Huge volume. And space is every time thing on ships. So currently, we see we have some challenges. Yeah? I wouldn't say issues. We have challenges, in-house challenges, because we are not a software company. We are coming from the maintenance business. We are used to sell maintenance to our customers or engines, but not software. And we have a lot of old sales guys that are not used to new technologies and stuff like that. And we need really to improve our scale up and stuff like that. And because of that, we want to get now the feedback of the whole company group, from the sales guys, from our service technicians, from our service leaders, and all that type of groups. And we prepared for this an MS Forms survey, where we also give them some more insights about the product, but also question them certain stuff like what do they need, what do they think is necessary for improvements, what developments should we prioritize and stuff like that. And we will go online with that next week. And then is the next step that we have an internal workshop planned in May with our high management, marketing, and co. And then we do this workshop, and then I hopefully have for me and Lucas our development roadmap for 2024, 2025. So to give you some little insights, what are possible future developments? First, we are thinking about, might be nice for the customer to have more access to different applications, just for the user feeling. So we are thinking about, the moment we have the different dashboards all in the cockpit application, but we are thinking like maybe using even application builder, extra visualization applications like for fleet management, maintenance, and oil sampling, and just have like the live data in the cockpit, in the standard cockpit. So that's one thought we have. Other, we want improve condition-based and predictive maintenance. So we have several ideas for extra sensor systems. Especially at Storm, we are currently testing the first permanent vibration measurement on site on a gas engine. And we have other ideas, for example, dynamic speed monitoring. So if you just use like the speed signal, you have the tooth wheel at the crankshaft, and you measure one round, one round, one round, one round. But you can use the pickup sensor for the speed signal also to measure in between each teeth. And then you get like a picture about the motion, about the acceleration and stuff like that. And you can get insights about the combustion out of that and of certain condition like the cylinder head ventils, if they are loose or not. You can predict that if you connect that to your valve timing and stuff like that. So then we also see like machine learning, especially for Koedood, because we have a pretty similar fleet size, that we have there like the fastest, the biggest database to introduce supervised learning. I already checked from the first 2 river drones some data with Jupyter Labs and stuff like that for building a condition-based or predictive maintenance model for the diesel particle filter. So that's my engineering background. I know a lot about it. And a diesel particle filter, it's basically a filter, and the delta pressure gets higher and higher and higher over the filter over time because the filter gets loaded. And at one point, you want to lower the delta, so you have to increase the exhaust temperature so that the certain amount of the soot and all that stuff in the filter can burn clean. And with that knowledge, if you connect that to machine learning, you can pretty easily, I think, build up a condition model for that. And I already found a linear function over a diesel particle filter and stuff like that with Jupyter Labs. Pretty nice. And also we are thinking about stuff like introducing unsupervised learning for anomaly detection for the engines. Much it.
question.
Thank you.
Yeah, thank you for the presentation, and it was really nice to see that you use a lot of open source components. And I've seen that you also use a translation manager. I'm not sure if are you using Digital Twin Manager or are you?
Actually, I didn't until 2 weeks ago.
Okay.
I had the feedback call 3 weeks ago because of our issues with the Data Explorer and stuff like that, and Raoul was asking me about it. And after that, I quickly built for the river drone a little asset, but for us it's pretty difficult because we don't have that many shard devices to have like a real structure. But for that, I have like the overall asset that's called the river drone fleet, and then I have beneath now each ship as a single because we have there like the ship is the main device, but it hasn't the data frequency to save cost. We only publish there the positional data from the AI stream, like every 3 minutes in average. So it's a low-cost device. And then we have the 2 engines as child devices in the asset structure. And I'm testing and looking currently into it. Yeah, we're looking there also for improvements.
Okay, and second question, how do you get these translations into the system? Are you typing this manual in, or? Because I'm asking, there's also, and I developed this, there's a small microservice you can have an API, so you can have an update, so upload a list of translations. So this could help if you have already this somewhere in the other system.
We did that until now manually. If you have there something,
yeah, you just can have a look in the GitHub repository. So there's something.
Oh, thank you.
I also have 2 questions. I'll start with a simple one, I would say. How do you connect the edge gateway to the internet? Is there an LTE modem integrated or what?
Depends a little on our business. We have, at Koedood, we use EVON routers already for remote access to the engines, but we have connected them to the ship network. So we use the ship network, but in between is still the EVON router. And on the Storm side, it depends where we are, if we have like a local network or not. We even are testing at the moment like our own data SIM cards with multi-provider for North America and Europe. There we pay like for each gigabyte data uses around €5 at that provider, and we introduced that for Scandisel because we implemented there now one ship that's seagoing and that's going regularly to Helgoland, and there you have to have a good connection. So it's multi-provider. It can use all 3 providers from Germany there, and so we have a stable connection there. So we are testing their different stuff, and we also have at Storm we use MB routers for remote access, and we also can use them for the network connection. SIM routers, double SIM, stuff like that.
Okay, thanks. The second one is, you mentioned that you give the dashboard to your customer for free for the first year. Who is your customer? Who are the persona that are using that?
That's the fleet owners. So they're operational managers and stuff like that. They check their data inside there. It depends also, like sometimes it's also their technicians. Like in the biogas market, my example customer, the main user is a service technician from the biogas plant, and he gives me a lot of feedback, what he wants more improvements in that case and stuff like that. So it depends on the customer. So operational or technical guys from the machine owner.
Thank you for your presentation. I have one question. Your future step, you have planned to analyze the condition-based maintenance and predictive analysis for the maintenance. But at the case, you need time series data to store it in somewhere in your system. But as you know, the Cumulocity has only MongoDB, so there is some limit to collect such kind of time series data. So what is your plan to how to collect data?
From my side, depending on our management, I would like to introduce Data Hub and Data Lake at one point. If the fleet size is big enough, we maybe have the possibility, because at Storm we have to rent now an extra server for MB Connect, because with that portal we got so big. We have the remote access worldwide to 1,000 engines that we need now our own server after 10 years. And maybe we can make there like something in between. We have to check that. But I hope for a data lake, but there's no decision yet.
Thank you very much for this interesting presentation. So my question is, which values are you measuring? I've heard that you're, for example, measuring the steam speed exhaustion, and you're also planning to measure the vibration. Do you also already got some insights from the engines, or?
You mean like the extra systems?
Exactly. Yes.
Yeah, at the current state, it's mainly what we have the pilot with the oil sensor. And now the vibration system was just installed 1-2 weeks ago. So we bought it. It's a system from Bachmann. We really work close together with them, and they have, like, out of the box, a system for their CPU. It's also the same CPU we use for our in-house engine control system. So we probably can adapt that easy in that type of market if they have our engine control system. Yeah, but I have no insights yet.
All right. Thank you.
Why do you need the data with a 2-second period? I mean, that's a lot of data, I guess, if you have so many data points as I know you have. And are you compressing the data before on the edge, or why are you pushing everything to the cloud?
We push everything to the cloud in 2 seconds. It's difficult. The combustion engine, in some cases, it would even be better to have higher frequencies. Like we had a company we work with visiting us, and they have a really crazy in-house built solution for knocking control remotely. They send every 20 milliseconds. Crazy system. I can tell you more about that later. I think time is up. I don't know. Okay. But, or anybody.
Thank you so much, Andrew.
Yeah, thank you. Thank you for having me again.